In this lecture, I am going to discuss an important topic of quantity surveying, in which I will show you how to calculate the quantity of concrete required for a staircase. I have tried to explain this in a simple manner to make it easy for you. Let's illustrate this procedure with the help of an example. Suppose we need to calculate the quantity of concrete required for a staircase with the given dimensions. The total height of this staircase is 3 meter. Height of first flight is 2.4 meter. The size of riser is 0.15 meter. Size of tread is 0.25 meter. Thickness of landing is 0.15 meter. The height of second flight is 0.45 meter from landing up to the bottom of floor slab. The thickness of waste slab is given as 150 mm or 0.15 meter. Width of each flight is 1.2 meter. The spacing between two flights is 0.15 meter and the width of landing is taken as 1.2 meter. First of all, we will do the calculations for flight 1, in which we will calculate the volume of waste slab and volume of all the steps. The number of steps will be equal to height of flight upon rise. Height of flight is given as 2400 mm and the rise is 150 mm. On substituting these values, the number of steps will be equal to 16. This horizontal length will be equal to tread length into number of steps. Tread length is already given as 250 mm and number of steps is calculated as 16. So the horizontal length will be equal to 4 meter or 4000 mm. To calculate the volume of waste slab, we need to know the dimensions of waste slab. The length of waste slab will be calculated by applying the Pythagoras theorem in this triangular section. So the length of waste slab will be equal to under root base square plus perpendicular square. Base of this triangle is 4 meter. Perpendicular is 2.4 meter. So on substituting these values, the length of waste slab will be equal to 4.66 meter. The volume of waste slab will be equal to area of cross section into thickness of slab. Area of cross section is length into width. Length is already calculated as 4.66 meter. Width of waste slab will be equal to width of flight, which is 1.2 meter, and thickness of waste slab is already given as 0.15 meter. So on substituting these values, the volume of waste slab will be equal to 0.84 meter. Volume of each step will be equal to area of cross section into width of flight. Area of cross section of each step is equal to area of this triangle and the width will be equal to width of flight, which is 1.2 meter. So on substituting these values, volume of each step will be equal to 0.022 meter cube. Hence the volume of 16 steps will be equal to 16 into volume of each step, which will be equal to 0.36 meter cube. So the total volume of concrete for flight 1 will be equal to volume of concrete for all the steps plus volume of concrete for waste slab, which will be equal to 0.84 plus 0.36 and the total will be 1.2 meter cube. Now we need to do the calculations for landing slab. Volume of landing will be equal to width of flight 1 plus width of flight 2 plus spacing between two flights into width of landing into thickness of landing. Width of each flight is 1.2 meter. The spacing between two flights is given as 0.15 meter. Width of landing is 1.2 meter and thickness of landing is given as 0.15 meter. So on substituting these values, the volume of landing will be equal to 0.46 meter cube. Now we need to do the calculations for flight 2. The first step will be to calculate the number of steps, which will be equal to height of flight upon rise. Height of flight 2 is 4500 mm. Rise is equal to 150 mm. So on substituting these values, number of steps will be equal to 3. This horizontal length will be equal to tread length into number of steps. The tread length is 250 mm and number of steps equal to 3. So on substituting these values, the horizontal length will be equal to 0.75 meter or 750 mm. The volume of waste slab for this second flight will be equal to area of cross section of this slab into width of flight. Since the waste slab has a trapezoidal cross section, so we need to calculate the area of this trapezium ABCD to know the exact volume. This trapezium can be further divided into two geometrical figures, that is triangle AMC and parallelogram ABMD. Area of triangle AMC will be equal to half of base of this triangle, which is AM, into height of this triangle, which is AC. AM will be equal to tread length, which is 250 mm, and AC will be equal to thickness of landing, which is already given as 0.15 meter. So on substituting these values, the area of this triangle will be equal to 0.018 meter square. Area of parallelogram ABMD will be equal to MD into thickness of waste slab. MD can be calculated by using this triangular section. MD will be equal to under root this base square plus perpendicular square. This base is the horizontal length, which is already calculated as 0.75 meter, and perpendicular is 0.45 meter. So on substituting these values, MD will be equal to 0.874 meter. The thickness of waste slab is already given as 0.15 meter. Hence the area of parallelogram ABMD will be equal to length of parallelogram, which is 0.874 into thickness of waste slab, which is 0.15, and the total will be 0.131 meter square. On substituting these values, area of trapezium ABCD will be equal to 0.15 meter square. Hence the volume of waste slab will be equal to area of trapezium ABCD, which is 0.15 meter square, into width of flight, which is 1.2 meter. The total will be 0.18 meter cube. Finally, we need to calculate the volume of 3 steps. Volume of each step will be equal to area of cross section of this step, which is a triangular section, into width of flight. Area of cross section of each step will be equal to 1 by 2 into base, which is tread length 0.25 meter, into height, which is rise 0.15 meter. So on substituting these values, volume of each step will be equal to 0.022 meter cube, and the volume of 3 steps will be equal to 3 into 0.022, which will be equal to 0.066 meter cube. So the total volume of concrete for flight 2 will be equal to volume of concrete for waste slab, which is 0.18 meter cube, plus volume of concrete for 3 steps, which is 0.066 meter cube. So on substituting these values, total volume of concrete for flight 2 will be equal to 0.246 meter cube. Finally, the total volume of concrete for the whole staircase will be equal to volume of flight 1 plus volume of flight 2 plus landing volume. On substituting these values, the total volume of concrete required for this staircase will be equal to 1.9 meter cube. So this was all about this lecture. If you like my content, please subscribe my channel and don't forget to press the bell icon so that you don't miss any updates in future. Thank you.